All right, here's a look at 2.3. We're going to deal with zeros, multiplicity of zeros, and end behavior. I'll find it kind of toward the end of 2.3 notes. So the beginning piece is we had worked through a little bit of a lab last week where we talked about end behavior. An odd function with some kind of where it's negative, a is less than 0, that leading coefficient a. You're going to have the behavior you see on the left there, versus if you are dealing with some kind of positive leading coefficient, you're doing in an odd function, you have what you have on the right, a greater than 0. That's it. That's the basic shape of it. You have to know those shapes. Even functions, there's the negative and there's the positive leading coefficient version of an even-powered function. So we dealt with x squared, x to the fourth, x to the sixth, etc. Odd functions, x to the third, x to the fifth, and so on. You have to know those end behaviors forward and backward, up and down if you want to call it that. But you want to describe the end behavior in these a and b functions down below. Just looking at that, the sign is negative, type is odd. You can shape it. You can get the general sense of what the end behavior, the arms and their direction, as you can see here. The stuff in between that I've got in purple here, no big deal. There's undulations, there's ups and downs, but basically end behavior is what's going on the end hands, where they're facing what direction on each polynomial. So next one. This one you have to do a little, if you FOIL it out in your head, you can see you're getting an x cubed for the right chunk and an x, 2x on the left. Altogether, you're going to have 2x to the fourth, blah, blah, blah. That's enough to get the type. Positive, even-powered, so the end behavior as follows. So that's the key, is knowing what to do. The internal parts we get from going after zeros and other key features. So finding zeros, for instance, you want to start with factoring. Always get out a power of x if it's possible, because that'll be one of your roots, 0. And then if you can factor what's left or use the quadratic formula, you can get the other two roots. Those are places outside of end behavior, and now you have a sense of where it crosses, and you get a pretty good picture of what you're graphing. So I can even, back this up, throw in a little quick graph here. If I do a quick cross here, this is a positive odd function. So it's coming in arm down, arm up, and I'm going to cross at 0, 3, and negative 2. So I can cross at, negative 2, 0, and 3, and I'm just roughing it, but that gets you a general shape. That doesn't take much effort. Next, you've got another odd function. Factor out a power of x, any coefficients to get your roots. This one again, positive odd, same shape. We have roots at 0, 2, negative 1. We could sketch that with no problem. Now the big key is this multiplicity thing down at the bottom here. Now, a 0 of a function is where it crosses or touches the x-axis. We want to be careful. It's not always a place where it crosses over. It's an intercept where it touches the x-axis. Because in this case right here, we're going to have a place where the x-intercept is just a graph touching there versus one that passes through. So if you have an even power to your factor, like you see on the left there, we actually say the power of it is its multiplicity, so it's to the power of 2, so multiplicity of 2. All even powered factors, the graph just bounces or touches at the axis, versus odd-powered factors with a multiplicity of whatever the degree of the power is, so in this case 3, is those go through, they pass through. So 2, 4, 6, 8 even powers of your factor mean it bounces at that root. Odd powers 3, 5, 7, 9, etc. are ones that pass through. Here's a quick graph of our b that passes through and our a that bounces. Again, I'm looking at, if I actually FOILed this out in my head, I'll have an x cubed on the right and x squared on the left when all is said and done. So that makes an x to the fifth. That's a positive odd end behavior. And then I know I have roots of b and a, but more specifically, it passes through a b and it bounces at a. So here we go. Here's the look at that. Bouncing at a, passing through at b. That's a big deal. Odd multiplicity versus even multiplicity and the behavior of those zeros in the polynomial. Big deal. All right, that should do it for this. Heading on to the next section.